Now, our topic for today is resolution of factor. That is, if you are given a single factor, you want to resolve it into its component. That is, vertical component and horizontal component. We now look at it. Which one is effective and which one is wasted? Now, for in the last video or last class, we were given two factors. We tried to resolve it to get only one. We call it resultant factor. What if you are not given that particular resultant factor and you want to know what are the two factors that they resolve to get that one? Now, from this topic, you will know how to apply your force correctly. Because in some cases, if you are given a certain work to do, or you want to carry an object, if you carry it wrongly, you might have even applied more than necessary force. But because you are applying it wrongly, you will not get the right result. For instance, let's say you have an object here and want to carry this object. Instead, you are going to carry this object from this point A to point B. So we are expecting you to apply your force directly like this. But if you apply it like this or like this, it means part of this force will be acting horizontal in horizontal direction, while the other part will be acting in vertical direction. So it means the horizontal direction will be effective one because it's the one that is doing exactly the work that you want to do. While the vertical one is what? It's just wasting. Now let's use this example to analyze the topic. The question said a man pulled a nail from the wall with a rope attached on it at an angle 30 degrees to the horizontal. At an angle 30 degrees to the horizontal, if the tension in the rope is 30 Newton, that is, that man is applying force which is equal to 30 Newton, and effective force to remove the nail is 28. So it is applying even more than necessary force. They calculate the force which tend to remove the nail, then the force which tend to bend the nail. Will he be able to remove the nail if he continued in that condition? Let's solve and see what will happen. Now, look at the diagram. So we have this is the nail, this is horizontal component. But the man applied the force like this. Instead of applying along horizontal component to remove the nail, but he applied it at a certain angle. Let's now solve this force into horizontal component and vertical component to know whether he will be able to remove the nail or not. Now, let's redraw the diagram here. We are going to have it like this. This is horizontal component. Then, this is the vertical component. But the man applied the force like this. This angle is angle 30. Then let's make it a right angle triangle. So this vertical component is same thing as this place. So we call it Y. Then this is horizontal component of the force. Let's call it what? Fx. Why this one will be Fy. Then this force itself is given, which is 30 Newton. We have 30 here. Now, to get horizontal component, which is effective one to remove the nail, is this one that is removing the nail, while the vertical one is bending the nail. Now, we have this triangle, this one have 90 degrees, this is hypotenuse, then this is opposite, this is adjacent. Now to get the horizontal component, we are going to combine adjacent and hypotenuse. We are going to use cos theta. Therefore, we have cos 30 is equal to adjacent fx over hypotenuse 30. Therefore, our fx is equal to 30 multiplied by cos 30. And cos 30 is 0.88. 0.866, which is equal to 30 multiplied by 0.866. So when you multiply it together, you are going to get 25.98. So we have, this one will give us 25.98 Newton. 98 Newton. So it means the effective force on the nail is 25.9, but he is applying 30. Now let's calculate the vertical component. Vertical component of the force. So therefore, the vertical component we are going to have sine. So we have sine 30 is equal to opposite Fy over hypotenuse 30. Therefore, Fy is equal to 30 multiplied by sine 30. So which is equal to 30 multiplied by sine 30 is 0.5. So Fy is equal to 15 Newton. So the force that is tending to bend the nail is 15 Newton. But the one that is removed the nail is 25.89. And the force that required to remove the nail is 28 Newton. You can see that the effective force that is removing the nail is less than required force. Whereas the man applied more than necessary force, but he applied it wrongly. Now the question now is, will he be able to remove the nail if he continued in that condition? Never. It will not, because the result of the force to remove the nail on the nail is less than required force. So when you want to carry an object, you want to remove, as a physicist or scientist, you should know how to apply your force. So the next topic will be on resultants of several forces.